Hi everyone. Today I will explain my COA project parts. Okay, so it's using benchmarking tools to test the my computer performance. So the tools that I use to is the Cinebench R23. So Cinebench R23 is a widely recognized benchmarking tools designed to evaluate CPU performance using the rendering task. So it use Cinema 4D rendering engine to simulate complex 3D scenes. So making the result is more reliable and relevant for creative professional engineers and system builders. So it only provide two testing, which is single core and multi-core performance test. So there will be also these two scores. So it can handle it will offer insight into how efficiently the processor handles parallel workloads or individual thread execution, which is multi-core test and single core test. So the main feature is CPU rendering benchmarking and the single core and multi-core testing, which can evaluate both individual core efficiency and overall parallel processing capability. So it's also available for Windows and Mac OS. And so it's in multi-core and single core test both in enabling to long stress test, which is 30 minutes, and the lesser time is 10 minutes. This can 30-minute test can support extended testing model to assess thermal throttling, cooling efficiency, and sustain performance. So it's a realistic workload simulation. So and side is detailed performance scores. So using the score to evaluate whether the pipeline and pilot efficiency is satisfied or not, uh, and the time is and the TCPU time. So here, okay. So I select Cinebench because it reflects CPU architecture efficiency in realistic workloads rather than synthetic micro tests. It rendering tasks utilize the ALU, FPU, and SIMD units, making it ideal for analyzing CLI concepts such as instruction execution, CAD hierarchy, and simultaneous multi-threading. So by running both single core and multi-core tests, it provides clear insight into processor scaling and pipeline depth and thermal stability. So the advantage of this is using real-world rendering workloads. It provides single core and multi-core, and it removes the thermal throttling and SMT overhead during extended runs. So it's also widely recognized. And the disadvantage is it's only measuring the CPU performance lah. And long multi-core test can cause high thermal load, potentially skewing result if cooling is insufficient. So different desktop, if the cooling system is different, maybe may affect the result as well. And benchmark scores may vary depending on background process and system power settings. So probably need to delete all the backgrounds and programs that runs when using the benchmark test. So it's also require careful interpretation to connect rendering score with COA metrics like CPI and bus latency. So next is a installation procedure. So my one is here. Okay. Performance test. Okay, so mine is to go to Cinebench download page. And download classes Cinebench R23. So and run it. Then so when you go into the official download page, it will be like this. And you can press the with downloads to download it. And after downloading it, it will be a exe file. So open it and you run into the like this. So the performance benchmark analysis and discussion. Uh, this session present the performance benchmarking activities conducted using past. Okay. Right. Two. So the next is detailed explanation for workload A and workload B. So for mine, okay, so for the workload A is to evaluate the processor parallel execution capability by running the 30-minute multi-core custom loop, which is 30-minute multi-core Tesla. It will continuously trigger complex rendering tasks. So the rendering tasks can see how many rendering tasks have the computer done. So by evaluating the time and the task done, you give the scores. So through the score, we can evaluate the CPU execution time, TCPU, and to output task level is also measured by the multi-core score, reflecting the number of rendering tasks completed in parallel, and pipeline saturation efficiency evaluated by comparing multi-core scaling against single-core performance, which the single-core score will be tested later on in workload B. So the workload B focus on evaluating single-thread execution efficiency by running the 10-minute single-core execution loop. This will only use one core to measure raw instruction to output without interference from multi-thread synchronization. By doing so, it can reveal how CPU leverage both clocks and intermittent core shifting to maximize single-thread performance. So the benchmark results are analyzed based on the single-thread instruction pipeline efficiency, which derived from the single core score. And maximum boost clock behavior, this can be observed during the test. And intermediate core shifting identifying whether the CPU migrates the single thread across cores to balance thermal or power constraints. This measurement provide insight into architectural clock for clock instruction throughput and highlight how well CPU optimize single thread execution compared to multi-thread scaling. So there is the workflow workload for there is the flowchart for workload A. So when the work start, we will launch the sorry, this out here. We will launch the Cinebench R23 first. Then we will select multi-core test and start the rendering task and collect score for CPU multi-core and analyze the multi-core score and 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 pipeline saturation efficiency will evaluate using the multi-core score. Then you record the result and screenshot. Same goes to workload B. It's actually almost the same. We'll run Cinebench R23 first and select a single CPU single core test, start the rendering task, collect score for CPU, analyze the instruction pipeline efficiency, compare the CPU single core score with the multi-core score, and we'll record the result and screen. Okay, so now I will tell the Cinebench app. So as you can see the interface here, the first job you need to do is to create a. So in default is this like that, no tick on the advanced benchmark. So by ticking it, you give advanced interface. So for the CPU multi-core, press 30 minutes and start. We'll start the test and change to 10 minutes and press the start for single core and you test for 10 minutes. Then here we'll indicate the marks, which is a score. So that's the interface of Cinebench and how to use it. So after that, we'll get the marks. Okay, so in this Cinebench, we'll get the mark, and for the multi-core test, I get 8,781. This this test was run for 30 minutes. So by getting this mark, it demonstrates that the CPU can effectively distribute tasks across multiple execution units, maximizing task level throughput while maintaining stable performance under stress. It also engaging all cores concurrently. the CPU's ability to keep execution pipeline filled and minimize stalls is test. So the multi-core score serves as a proxy for CPU execution time, where high score correspond to lower effective rendering time, indicating higher efficiency in pipeline utilization and throughput. It's also the score also established the foundation for comparative analysis with single core benchmark, which will be used to compare to single core score later, and as a sign bench point index. The higher index of sign bench points index will approaching the physical core would indicate efficient parallel utilization, while lower value suggests synchronization overhead or memory bottlenecks. So the next is a single core test result, which is 1653. So this mark provide a direct measure of how efficiently CPU can process instructions sequentially. So this represents the processor baseline as capability in handling sequential workthrough and reflects the effectiveness of its instruction pipeline, branch prediction, and CAG hierarchy when operating under constrained conditions. A higher core score correspond to stronger IPC performance. So the score indicates a mid-range efficiency for modern model CPU. The marks also used to compare to get the sign bench point index later. So we'll after using the multi-core score divide by single core score, we get 5.3. So this value indicate the processor have moderate parallel efficiency with some performance loss attributable to synchronization overhead, cache coherence limitation, and memory hierarchy bottlenecks. So overall is the Intel Core i5-13420 delivers strong single-thread performance to boost clock optimization, while OS scheduling introduce minor variability through core shifting. So comparing to multi-core score, which getting the sign bench point index, it highlight effective but not perfect scaling, underscoring the importance of memory subsystem design and pipeline saturation in achieving higher parallel efficiency. So that's all for the testing.